Welcome to my video on the TI-84 plus CE calculator. In this video, I want to talk about transforming trigonometric functions. The last video, we went over the trigonometric functions and how you can plot them using your TI-84. This time I want to expand on that idea, and we're going to look at the more general form of the sine function. And this could be cosine or tangent, or any of the trigonometric functions. So I'm just using the sine because it's probably the most commonly used. Okay, a sine, and then this in parentheses, bx plus c plus d. So that'd be the more general form. Where this a is going to be the amplitude. That controls how big the sine function is on the y-axis. And b controls the period. So how many periods occur over a given period of time, or whatever the dimensions are. And then c is the horizontal shift. So that moves it back and forth on the x-axis, and then d is a vertical shift, so it moves it up and down on the y-axis. And I'm going to go over examples of all of these, kind of give you an idea of what I'm talking about exactly. So first of all, we're going to look at an amplitude, and that is going to be, we're going to start out with y1 is equal to the sine of x, y2 is going to be equal to 2 sine x, and we're going to work in the radian mode. Okay, so let's get our calculator up here, turn it on, we'll clear it. Now let's hit the y function. First of all, we want to enter the sine, so we're going to do sine, and then we want to put the x, close the parent. Now let's arrow down, and now we're going to do 2 times the sine of x. Okay, so we've got two things here. The y1 is going to be the sine x, y2 is twice, so we're upping the amplitude. Let's graph that. Okay, there's the first function, and there's the second one. Now, I want to make sure that we're getting the best presentation here possible, so I'm going to go into Zoom, and I'm going to go down to Z-Trig. We covered this earlier, and so that gives us that. Now, okay, it was already in a good position to show these functions on the trigonometric. Okay, so there's the blue is the original one, and then the 2 sine x is the red, so it's twice the amplitude. We can kind of verify this, hit the trace function. We'll go over a little bit. Now we're on the blue one. So it looks like we're right there at about 1, so that's going to be the pi over 2. Now if we go up here, it's going to be y is equal to 2, so it is doubled on the red. So that's got to do with our 2x factor. So now let's look at if we want to change the period. And that's going to be with this b right here. So if we want to put y1 is also equal to sine x, y2, in this case now it is sine 2x. So the 2 does not go out front in the amplitude, now it goes in here with the x function. So let's do that. Let's clear everything. Let's go into our y equals. We're going to leave the sine x the same. Let's go down here to this, and let's see if we can delete just that. Okay. Arrow over, and we want to add in a 2x. Close the parent, and we are in radian mode. Okay, let's graph that. Okay, there's the original sine x in blue. Now we see the red. It has the same amplitude because we didn't change the amplitude. This a is just equal to 1, but we did change the period. And so that's the red. We've upped the period twice. So you can see on the, we go through one period here on the blue, but on the red, we've gone through 2 periods in the same amount of time. So we've doubled essentially the frequency of the wave. So that controls the period. Now let's look at a phase shift. So y1 is equal to our sine of x. y2 in this case is going to be the sine of x minus pi over 4. So pi over 2, that's going to be 45 degrees. So we're going to shift it by 45 degrees because that's in radians. And we know that pi over 2 radians is equal to 90 degrees. So pi over 4 would be equal to 45 degrees. That just gives us an idea. So let's clear our graph again. Let's go into our y function and see what those look like. Now we want to go down and change the second one. We're leaving the first one the same. That's our reference. Okay, let's delete, and delete. So put in x. Now we want to do a minus. Now I want to put in a second set of parens here so that we're very clear. Okay, second mode, hit the pi function, divided by 4, close that parent, and then close the sine parent. All right, now let's graph that. Okay, there's our sine function in blue. Now here is the phase shifted. You can see it shifted it by 45 degrees in the red. And so that's all it did. It moved everything over essentially to the right. The negative phase shift moved everything over to the right. So that gives us a phase shift of 45 degrees, or pi over 4 radians, since we are in the radian mode. And we will look at one more thing. Let's clear all that. Now we want to look at a vertical shift. So y1 is still equal to sine of x. y2 now is going to be equal to the sine of x, and then we want to add 1 to it. So we're going to be moving it up 1. All right, let's go into what we're going to graph. That's sine x is good. That's our original function. Let's go over here and we want to delete some of this. Now we want to close that parent. We're just going to do sine x, but now we want to add to that 1. Okay, so we've got the sine x plus 1 in our input there. So let's graph that. And there's our original blue. Okay, and there is the same sine wave, except we've added 1 to it. So let's verify that with our trace function. Let's go over to, there's pi over 2, so that's 90 degrees. Now let's look at the other one, go up, and that is double. Y is equal to 2. So we've added 1 to everything is all we did here. Well, I hope you learn a little bit about the transforming trigonometric functions. It just expands our ideas and concepts and how we can use our TI-84 to graph trigonometric functions. Well, thank you for watching.